So for our micro image, we decided to do a snowflake. We had some extensive knowledge on the crystalline structure of that, so we decided to kind of build on that. So to begin with, I'm going to go over some of our content standards for math, for art. So the first one is going to be primary and secondary colors. You can definitely see their influence in our own artwork. A lot of the light that was like reflecting from our pieces really use the primary colors heavily within the composition. Moving on, we talked a lot about visual texture and actual texture within our own group. Visual texture would be what we actually produced using the materials such as salt and vinegar. And that's just how that affected the pigment and how we achieve kind of a different visual complexity within our composition, where actual texture would be how the piece felt when it had the salt on it. And it's nice to see that both of these can work hand in hand, and you can apply it to your own classroom by having the students look at each material and understanding the property, such as dehydrating the water that's in the pigment. Balance within the composition is also really strong. We decided to have a focal point towards the bottom right-hand corner for you guys how you're viewing it. And then also balancing the rest of the composition using both organic and geometric lines, which geometric shape is used to create kind of an orderly crystalline structure within the snowflake itself, where organic shape and line can be seen throughout the piece to create movement, especially if you look at our actual painting. We use a lot of organic line to utilize our shape. And finally, the repetition of color to build unity. I touched on this before when we were talking about the primary and secondary colors. Pretty much, because we use the same color, we can create a sense of unity within our piece and have the viewers be interested in the whole entire thing as they're looking through it, and creates a dynamic composition. We also have a couple in progress images for us to look at while we're switching over.
Alright, so there's our original drawing that we did to the snowflake, and then there's us painting it. So those are two of our in progress photos for you guys. So now I'm going to talk about the science concepts that we discussed in our group. We started with the crystalline structure of the snowflake, and so as you can see from our original image here, snowflakes are six-sided crystal, so that's where you get this from. This is kind of where they start out at, and then they branch off from there. And they form the crystal structure due to the angle of the bonds between the hydrogen and oxygen and water, and that's how you see that. And so then we talked about atmospheric conditions. Snowflakes form based upon the atmosphere around them. It's really heavily dependent on the amount of moisture in the air and the temperature. And here is kind of a graph of that. So this shows how the air temperature along the bottom here, and then the water supply, and those are directly proportional, because if it's too cold, or it can't hold moisture in the air. That's one of the things with Laramie, for instance. We sort of have two winters. We have our cold winter in like January, where it's too cold for it to snow, so that's why we don't get much moisture at that time. And then it warms up a little bit, so we get a lot of our moisture in the springtime, because the air is warm enough to hold moisture for it to condensate. So here's the stellar snowflake. That's kind of what most of us think of. And that's sort of like the regular Snowflake image. But you can also get some like columns. You can get like hail sort of stuff up here. You know, really dependent upon the temperature and the water supply in the air to determine the structure of the snowflake. We also talked about light properties. As you can see in our image, we decided to really heavily show the colors in there because the snowflake shows up white due to all the different colors reflecting out of it. And so, like, as you can see from this, it's kind of clear, but you can see all the colors coming through it because this is due to scale. That's our next one is scale. So we went from a macroscopic image down to a microscopic image, and when you go down to the microscopic level of the snowflake, you really get to see the colors coming out of it that produce the white look of snow. And then the metamorphism and deposition is due to the, as the snowflake falls, depending on where it's at in the atmosphere and the temperature of that part of the atmosphere, it'll change shape. So like as it's falling, you can change shape multiple times before it actually hits the ground. And so that's pretty interesting.
So how does this all relate to our experience that we had this past, I guess, 3 or 4 sessions to some published research? And so the article that we were given was the aesthetic approach to the teaching of science, and that was by Zabrowski in 1982. Basically, this article focuses on how individuals, especially children and students, will make discoveries using their aesthetic curiosity. The concept wasn't not just to provide an educational experience, but to acknowledge and provide opportunities to play and explore. So for example, in the article, I think Zabrowski talked about how you can give students marbles or bubbles, and the main purpose is not just for them to understand Newton's first laws about marbles going down a track or surface tension of a bubble, but it's for them to use these resources, explore and play, and make their own connections. Let's see what else. By also this experience that Zabrowski talks about is just providing hands-on experiential opportunities for learning. They're able to learn while they are doing something. 2 strategic levels of learning that Zabrowski talks about is perception and imagination, as well as sensible intuition. And by providing these 2 levels, you're acknowledging both disciplines of art and science into the experience of the student and the learning. But to reflect this back onto our experience of art and science, we were given a whole bunch of supplies, resources, information, and we were able to work together to utilize our strengths, collaborate, make defined planning and design processes, and focus on all of the art and science concepts that we had talked about into creating a beautiful piece. And so that was just basically the tie for Zabrowski, that it's not just about learning science, but it's actually that experience that you're having.
And that experience can also bridge that gap. So also building off that, we learned a lot from the materials. For instance, you guys have never really worked with the salt, with the pigment, and understanding how that changes everything. And you can take that and apply that to both scientific concepts, which is like dehydration, and then also chemical reaction. And then as well as the aesthetic approach, talking about texture, both applied and actual texture. And then it's just lessons like that that are really creative and helpful to engage students that are both really creatively driven, and then those that are really academically driven that really want to understand the world around them.
All right, nice job. Thank you.